Welcome, students. At this point, we've looked at arithmetic with integers and decimals. Next, we're going to look at arithmetic with fractions. But before we get into adding, subtracting, multiplying, and dividing fractions, we're going to need to reduce them. And before we do that, we need to look at factoring whole numbers. So we're going to start by looking at factoring whole numbers. And to do that, we're going to need a definition of what it means to factor. To factor a whole number means to write it as a product of two or more whole numbers. The numbers being multiplied are then called factors, and the original number is called the product. Let's take a look at an example, and let's go through it. Let's take a look at 24 and the different ways that we can factor 24. Now, to factor a whole number means to write it as a product of two or more whole numbers. So we could write 24 as 2 times 12. We could write it as 6 times 4. We could write it as 3 times 8. We could also write it as 1 times 24. Each of these is a way of factoring 24, writing it as a product, and each of these numbers within the products are called factors. They are factors of 24. So if we wanted to list them out in numerical order, 1 is the smallest, and then 2, and then 3, and then 4, and then 6, 8, 12, and 24. So when we factor 24, we can see that we can do that in multiple ways, and we end up with a total of 8 different factors in the end. Let's look at another example. Let's take a look at the number 7. Let's factor that. Well, the only way we can do that is by writing it as 1 times 7. There's no other way of breaking it down. And so here the only factors are 1 and 7. And there's a big difference between these two numbers. We have names for these types of numbers. The second number, 7, we call that prime, and a prime number has only 2 factors, 1 and the number itself. 7 is prime because it has only 2 factors, 1 and then 7, which is itself. On the other hand, 24 has a different name. 24 is called a composite number. A composite number has more than 2 factors. We can actually write out several examples of prime numbers and composite numbers. 2 is prime because we can only break it down as 1 times 2. 3 is prime because we can only break it down as 1 times 3. 4 is composite. We can factor that as 2 times 2. 5 is prime. 6 is composite because we can write it as 2 times 3. 7 is prime. 8 is composite, can be written as 2 times 4. 9 is composite, 3 times 3. 10 is composite, but then 11 is prime. And we could keep going. I'll do this quickly. 12 is composite, 13 is prime, 14 composite, 15, 16 composite, 17 prime. And in fact, these lists of numbers go on forever. There are infinitely many prime numbers, and there are infinitely many composite numbers. The lists would continue forever. We won't continue writing them because we don't have an infinite amount of time. But there's no largest prime number. They never really stop. They keep going on and on forever. Now, there's a special type of factorization that is kind of the most important, and we call that the prime factorization. The prime factorization is a factorization of a number that includes only prime factors, and we can figure that out with a factor tree. Let's take a look at 24. Now, we can break 24 down as 6 times 4. But then we can keep going and break them down even further. 6 is 3 times 2. 4 is 2 times 2. And none of those will break down any further. Those are all prime. So we say that the prime factorization of 24 is 2 times 2 times 2 times 3, because those are the prime factors we have when we break them down. I will generally write prime factorizations in numerical order. I'm a little OCD. It's just kind of how I do it. So we've got 2 times 2 times 2 times 3. There's another way of writing that. If we want, we can use an exponent. Because the factor of 2 appears 3 times, we can write that as 2 cubed times 3. Either one of these is equally acceptable. Now you might be thinking, but 24 can be broken down in other ways. It's not just 6 times 4, it's also 8 times 3. But it doesn't actually matter which method we use. So long as we break it down all the way, we should get the same prime factorization. 8 is 4 times 2, 4 is 2 times 2, and if we look here, we still have 2 times 2 times 2 times 3. We end up with the same answer no matter how we set up our factor tree. Because of this, we say that a number has a unique prime factorization. There's only one possible answer for what a prime factorization is going to be. Now, factoring numbers and recognizing factors of numbers is important when we're doing things like reducing fractions, and then later on when we're looking at polynomials. So I want you to look at a few of the videos linked below to get some more practice factoring numbers.